Welcome to video 3 in the Making Data Count series, Basic Principles of Data Fitness for Purpose and Data Quality. Before embarking on analysing a data set, it is important to consider how fit for purpose it is. You wouldn't want to spend lots of time analysing some data and drawing conclusions from those findings if the raw data isn't up to scratch. For the purpose of this video, we will draw on the NICE real-world evidence framework, and that looks at quality and relevance. Let's have a look at quality first. There are two things to consider. First up is completeness. Completeness refers to the percentage of records without missing data at a given time point. In the case of the root, we see that services often don't have the end of episode rating for all service users. And because the data isn't complete, we can't report on change over time. Next is data accuracy, and that's how closely the data resembles reality. So how do you do this? You could look to a gold standard, something you trust to be accurate, and compare it. So perhaps you might look at caseload numbers. You know, for the last X number of years, your mainstream school services caseload has averaged at around 300 pupils per academic year. So you would expect that to be roughly similar for the year 2022. Say you look at your data and it seems that you only have 30 pupils this year. Is it likely that this is an inaccuracy? Yes, perhaps these have been inaccurately coded and are instead represented in your special schools caseload. You can also just look at your data and ask, does this resemble what I was expecting? Is there something that looks a bit strange? So quality is about completeness and accuracy. Now let's consider relevance. To determine relevance, we look at data content, data coverage, and data characteristics. Data content, does the data contain sufficient data elements? Now in the root we specify mandatory and optional fields. Adding more detail to the optional fields increases the ability to understand patterns and outcomes in more detail and granularity. Basically, does it have the data we need? If we're trying to understand prevalence by borough, have we collected borough information? Data coverage. So how generalizable are findings from the analysis? If you're doing data analysis on routinely collected data, you've got fairly good data coverage already. Here we want to think about things like how representative are the patient characteristics that I'm looking at in my data set? Are they similar to real life? Have the patients represented in this data set gone through similar care pathways, etc., etc. Other data sets, such as those from a clinical trial, may have poorer data coverage because it will be representing a narrower subgroup of the target population. Data characteristics. This is the size of the sample and length of follow-up. In the root, for example, we aim to enhance data characteristics by requesting that episodes of care contain a follow-up, end of episode TOM score. Users can also opt to enter as many interim TOM scores as they like. Similarly, the root will only run a report once a minimum number of cases, that's 6, in any given category has been obtained. When sample sizes are much smaller, we have less confidence in our analysis. So here is an example of a spreadsheet of TOM's data that a speech and language therapy service wants to submit to the root. You can see that they've not been recording the primary medical diagnosis, which will limit how they can interpret the findings. For example, knowing whether an individual has had a stroke or a progressive condition such as motor neuron disease is really relevant because depending on the underlying condition, you may have different expectations as to what a good outcome looks like. Do you hope to see improved outcomes at the end of the episode of care, or is maintaining a level of function a good outcome for that person? There are, of course, risks to using unfit data. At the service user level, if you don't have all the information at hand, then you may make incorrect decisions about their care. At the service level, you could make the wrong decisions around service planning or commissioning, which could mean a lot of wasted effort and resource. And at a profession-wide level, if we're not confident in our data, how are we going to make big decisions to try to improve people's lives? How are we going to make the case for our profession to the government and the public, etc.? And that brings us to the end of this video.